Hey there, everyone. This is Mystic Fish, and welcome to episode 3 of our Factorio Expand a Base. In this series, we are trying to design a base that we can more or less upgrade in place all the way up to a mega base. I know last episode we talked about working on a little jumpstart design to get us through a lot of the early research. And I do want to make that, but as I was thinking about it, I realized that that's going to be a lot easier to design if we understand more about how the whole base is going to work first. So I do think we kind of want to design things sort of back to front because that's actually going to help us with the producing the upgradable blueprint. So if we start with the final thing, then we can cut pieces of that away to make earlier versions of it. And so that's going to be our way of going about things. And so I think I'm going to come back to the jumpstart base almost really at the end. And so I think for this episode, I'm going to pivot and let's just put together a little bit other infrastructure that we're going to need. And for that, we're going to work on a basic rail system. So the nice thing about a grid-aligned rail system is that we can do the designs up front. Because it's grid aligned, then we can make sure that the rails snap together and meet in the proper way. And we can do this all of the signaling up front, and then we don't have to worry about correctly signaling things. And as it turns out, we can get pretty far in a rail network really with just 2 designs. And so and that is for a T-section and then a set of straight rails. Okay, I obviously need to enable cheat mode again here. There we go. Okay, so let's see how this is going to work. We're going to come over here. And we need to come down there so that we end up even with the edge of the grid. So that's good stuff. Let's grab this. All right, that will go that way. Now, I like to run the, for my rail designs, I like to run the electricity up the middle. And so this is where we want those things to go. We'll get rid of the extra electric poles around the edges that we don't need once we have laid this all out. But this is the basic idea. We to make a T-junction, and I'm going to do the T-junction first because if we do that and we do it right, then we can extract the straight rail segment out of it afterwards, and that will allow us then in the other order to lay down straight rails first and then later turn that into a T intersection. So, and that's in line with this sort of expand a base philosophy here. So let's go ahead and get rid of some of this stuff. Let's see. Now I want to keep lights around this stuff. So I'm a little curious if we will have enough room here if I put lights around this stuff if I come down here. Okay, that hits the lights. Okay, so this is not exactly where I want this to be. So let's get rid of these rails. I think we need to move these out by one. Okay, so then we'll go from here down to straight to there, and from here down to there. All right, let's see now if we then rotate these guys around. Let's see if we can successfully dodge around those lights around that center power pole. So let's see, I think I want to come like that. And that seems to work. Oh, there it is. And then across here. And then we need to go there. Flip this. Okay, now let's talk signaling. I like to use right-hand drive for my rail designs. I live in a country where people drive on the right-hand side of the road, so that makes it easier for me to remember. I know a lot of people prefer left-hand drive because it means you can put the signals on the inside of the tracks, and in theory, I guess that saves some room on the outside. I'm not actually planning on putting anything into these grid segments other than the rails, so I'm not really that worried about saving the extra space, and it's a lot less confusing for me if we put if we do right-hand drive, because that's how I'm used to driving myself. So we will do that. Okay, so now we need rail signals on the exits. And then I think we want some symmetry here. So we need the chain signal going into the intersections. And then this will be going in. And then this is the exit going this direction. And we want to line these up because that, I think, will give us rotational symmetry for these two on the straight segments. So that's good stuff. And we need one there, and we need one there. Okay, so now let's take a look at the rail blocks that we have. So as you can see here, the way that we've got this laid out right now, we have a single rail block that is pink in the center here. And so that means that that if anybody that's approaching the intersection, we can only have one train going through at a time. Now, we can do a little better, right? Because it should be possible for a train to come in from this way and go straight up this way, and for a train to be coming in and going straight. And those never have to cross, and they shouldn't interfere with each other. But right now, they would have to wait for one another, and that doesn't really seem to make a lot of sense. So I think we can fix that just by adding a few chain signals around the outsides here. And now we can see that we actually, the intersection part is divided into three different rail blocks. There's a pink one in the upper right, there's a dark blue one in the upper left, and then there's a yellow one along the bottom. And that is actually okay. So like, for example, looking at the yellow one, we can have a train coming in here and a train coming in here going this way. And they clearly have to wait for another because they're both trying to go this way. Or a train coming this way or a train coming this way, they'll have to wait for each other because they have to cross and so on. So, so I think this is actually minimally signaled. So that's good stuff. So let's grab, let's get some light. Whoop, I don't want the rails. I just want the lights. Let's get ourselves some lights around this stuff. And this one. We only need the ones around the edges, so then we can copy that and get them in here like this. Okay, I think that's our T-junction, mostly. What we can do is we can get rid of... I'm going to leave the corners in because that makes pulling the blueprint easier for something that's grid aligned. So now I can take a blueprint, grabbing all of this. This is going to be a T-junction. You are going to get a T. Snap to grid. Here 100 by 100, and I think we have to offset by 2 to line things up. And so yes, the rails line up with the edge of the grid, which is what we want. That way we can stamp them down next to each other and the rails will actually connect. Okay, so let's create that one, put that here, and then I can right click to remove these corner power poles from the actual blueprint. And so now you can see it's just the rails and the stuff that we need. Okay, so next we want to turn this into a straight rail segment. And to do that, we just get rid of all of the stuff related to the T. So let's restore this. And now, because we've only deleted stuff, it should be the case that we can put a T-junction over top of this, and because we have straight segments, then we don't need any chain signals here. So then let's grab this. These are going to be straight rails. Snap to grid, 100, 100, 2 and 2. Create the blueprint. Then we can get the corners out. Save. Okay. Now, there's a few things I want to test here. So first, I want to test that if I put this down, the straight one, and then I rotate it twice the other way, everything lines up in the same spot, which it does. So that's good. So then we don't have to worry about which direction this happens to go. Okay, the next thing that I want to test is that I can successfully put a T-junction down over top of this, which that worked. And then I can do it the other way as well. And so that worked. Okay, so that looks good. And then the last thing that I want to test is I want to count how much space is in between these here, so these signals here. So ideally what you want is we want a train to be able to sit outside of the intersection. Right, it's no good if it gets stuck in an intersection. So we make sure that there's space beyond the intersection, wherever it exits, for the train to sit. And so I want to count the white brackets here. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's room for a 1/8 train to sit right here where we have it. So a train could come out here, and there's room for it, and it can sit right here. And if it has to wait for the next intersection it goes through, that's fine. But then other trains that are like going this way through this one, or turning or going this way, are not going to be blocked by it. So that's a good property to have. So we'll be able to use 1/8 trains. Those of you who watched my prior series on building a cellular megabase will remember that we used 1/8 trains there, and that worked out great. The 1/8 trains are plenty fast, and they get plenty of throughput, and without really creating a lot of train traffic. So I think that's where we're going to be designing our base around 1/8 trains as well in this time around. But that's it. Okay, so that's it. This is our entire, believe it or not, this is our entire rail system. We can get really far just with straight rails and T-junctions in terms of routing things around the base. We are going to need some additional rail segments when we get to loading and unloading trains. But as far as the actual core network of transporting things over distance, this is it. 2 blueprints is enough for our rail system. So let's go ahead and no, that wasn't right. I don't want that thing. How do I delete this? Shift and right click. There we go. I want a blueprint book. And then we're going to call this rail system. And then we're going to put our straight rails and our T-junctions in there. Okay, that is it. That is it for this episode. I just wanted to take care of things. I think I'm going to shoot for smaller, bite-sized episodes that just look at doing a couple of small pieces of the design. We'll see how that works out. But that way, if you're not interested in that particular thing, you can pretty safely skip that episode if you like. But also, I think these episodes may make a nice future reference to be able to link back in terms of, being able to link out or show people, where we use various designs, how they were put together, and why they were put together that way. And so in particular, I just want to call out there are no signals at the edges where they connect to the next one. And that's because, like I said, we want to be able to have a train sort of sit between signals. And it's going to be long enough that it will sort of straddle two adjacent grids, or, you know, rail grids, rail tiles, rail grid tiles, whatever we're calling these things. So that is intentional that we have left these off here. And it's intentional in the case of the straight rails. If we look at it, you know, in theory, if it was just straight rails, sure, we could move these signals into the middle. But if we leave them here, then that lets us stamp the T-junction on top of them, right? Because if we put them in the middle, then they'd be in the wrong spots, right? Like you can't have one here because this needs to be a chain signal. So, and you know, like I said, I want to be able to upgrade things by stamping new blueprints down over top of the existing ones. So that is why that is all designed that way. And so, yeah, I guess that's it. So that's what we have for this episode. So as always, thanks for watching. We'll see you next time. Until then, bye.